Hi guys, so today we're going to learn our next type of solving quadratics, and that is solving using inverse operations, and specifically by using square roots. Okay? So we can use square roots to help us solve special types of quadratic equations, and those equations involving some type of squared quantity. Okay? So let's make sure we first understand a very basic concept. Okay? So we're going to solve the following equations for all values of x, and we're going to write our answers in simplest radical form. Okay, so here we have x squared equals 16. So right now, this x has a squared with it. So to do the opposite of squaring, what I'm going to do is I'm going to square root it. Okay, so here I'm going to let me use another colored pen. Let's do blue. Okay, so here I'm going to square root it. Okay, because the square root and a square are opposites, what you do to one side, you need to do to the other. Okay. So the square root and square undo each other because they are inverse or opposites, leaving me with just x. Okay. Whenever you square root to solve for a variable, you're going to put a plus or a minus in front of it. Okay, and I'm going to explain why in just a little bit. Okay. So we should know that the square root of 16 is 4. Okay. So I have two solutions here. When I write plus minus 4, really what it means is that x equals positive 4. That's one of my solutions. And x equals negative 4. Okay. It's just sometimes mathematicians, we get lazy. So instead of writing positive 4 and negative 4, we write it as this, plus or minus 4. Okay. I will accept both, so that is up to you. Okay, so let me explain why it is both positive 4 and negative 4. Okay, so here, let me check it. So to check our solution, all we need to do, we learned this from the beginning, is plug it back in. Okay, so I'm going to plug in that 4 in. Okay. So, plug in. 4 squared is 4 times 4, so 4 times 4 is 16. Does 16 equal 16? Yes, it does. So positive 4 is a solution. Okay, and then the other solution was negative 4. Okay. And we're going to see if this is true. So negative 4 squared is negative 4 times negative 4. Negative 4 times negative 4 is 16 as well. Does 16 equal 16? Yes, it does, and that is why negative 4 is also a solution. Okay. So that when we square root, right, we know that whenever we square anything, it turns positive, right? So whether it was a positive 4 or a negative 4, when we squared it, it would still give us a positive 16. So when you square root for a variable, make sure to have that plus or minus. Okay. So let's do the next one here. We have x squared equals 100. So I want x by itself. So opposite of square is to square root. What I do to one side, I need to do to the next, to the other. Right? Square root and square, they undo each other, leaving me with x equals plus or minus square root of 100. Square root of 100 we know is 10. And so my answer is both positive 10 and negative 10. Okay. And then here's the next one. Okay, x squared equals 20. So I'm going to undo the squares by square rooting. What I do to one side, I need to do to the other. Square root and square undo each other, leaving me with x. Okay. Plus or minus square root of 20. Okay. So we need to do this in simplest radical form. So remember, the perfect square in 20 is 4, right? 20 is 4 times 5. So square root of 4 is 2. 5 doesn't have a perfect square in it anymore other than 1, and so this is my final answer. Okay. So the key here is that the inverse operation to squaring is taking a square root, right? So these are opposites, right? So just like we have addition, the inverse is subtraction, right? And how we get rid of one, we do the opposite, the inverse, right? If it was multiplying, right? The inverse is to divide. Opposite of dividing is to multiply, right? So same thing, if we have something to a squared or a power, the opposite would be to root or radical it. Right, so the key here is that inverse operation to squaring is taking a square root. Okay, but when you do this, you always introduce both a positive and a negative answer, right? So that's why we had plus or minus 4, plus or minus 10, plus or minus 2 square root of 5. Okay, squaring is a non-reversible process, meaning that you can't just simply undo it. Okay, so here we're going to solve each of the following equations for all values of x by using inverse operations, so using this that we know. Whenever you solve for a variable, what we're actually doing is we're going reverse order of operations. Okay, right? So normally we do this. When we solve for a variable, we go reverse. Okay. So what we're actually going to do is we're going to deal with addition, subtraction first. Then we move on to multiplication and division. Then we move on to exponents. And last we do grouping. Okay. So the first thing I'm going to do, here I have 2x squared plus 10 equals 18. Okay, so the first thing is actually addition and subtraction. So opposite of plus 10, I'm going to subtract 10 here. So 2x squared equals 8. After addition and subtraction is multiplication and division. So I'm going to get rid of this 2. Since it's 2 times x squared, the opposite would be to divide. I have x squared equals 4. And then the last one here is exponent. So opposite of square, we're going to square root it. Okay. So square root and square undo each other. Plus or minus square root of 4. Okay. We know that square root of 4 is 2. So I have two answers, both positive 2 and negative 2. Okay. Let's do the next one here. Okay. X minus 2 squared equals 25. Okay, so while we do have addition and subtraction, it's inside the grouping. So I'm actually going to deal with this exponent first. Okay, right? Because here I have an exponent and then I have a grouping. Okay, so I'm going to undo the exponent first. So opposite of square is to square root. Okay. That leaves me with x minus 2 equals plus or minus square root of 25. Okay. We know that the square root of 25 is 5. Okay. And so now I have two answers. One is x minus 2 equals positive 5. And the other one here is x minus 2 equals negative 5. Add 2 on both sides. I get x equals 7 here. Add 2 on both sides. I'm going to do x equals negative 3. Okay, so I have two answers. One is x equals positive 7. The other one, x equals negative 3. Okay, so we're going to do this one next. Okay, I love this one because it shows us all of them here, right? We have a grouping, that parentheses. We have an exponent. We have a multiplication. And we have a subtraction here. Okay, so whenever we're solving, we go reverse order of operations. So the first thing I'm actually going to do is get rid of this minus 50 by adding 50. Okay. What you do to one side, remember you got to do to the other. Okay, that leaves me with 100. Okay. Sorry. It is not 100. It is 200. Sorry, 150 plus 50 is 200. Okay, then after the addition, subtraction here, I'm going to now deal with the multiplication and division. So since this is 2 times all of this, I'm going to get rid of it by dividing by 2. Right? I'm left with x plus 5 squared equals 100. Okay, so I just finished multiplication and division. Next would be exponents. So here I have x plus 5 all to the second power. So the opposite of square is to square root. This would leave me with x plus 5 equals plus or minus square root of 100, which we know is 10, so plus or minus 10. Okay, so I have two options. Either one, x plus 5 equals positive 10, or x plus 5 equals negative 10. Right? Subtract 5 on both sides. Here I get x equals 5. Subtract 5 on both sides. Here I get x equals negative 15. So my two solution zeros or roots is either x equals 5 or x equals negative 15. Okay. However, of course, right, there's no reason our answer must come out as rational numbers as in here, right? It doesn't have to be nice numbers like positive 2, negative 2, 7, negative 3, 5, negative 15. That doesn't have to be true. Okay. Sometimes we have irrational numbers as well. Okay, where numbers cannot be written as fractions. They are not as nice and simple. In these cases, all we do is express our answer in simplest radical form. Okay, so that's what we're going to do here. We're still going to go reverse order of operations. So opposite of minus 2 here, I'm going to add 2. Left with 5x squared equals 40. Then, since this is 5 times x squared, I'm going to divide by 5. So x squared equals 40 divided by 5 is 8. Then I'm going to deal with this square by square rooting it. That's the inverse. Square root and square undo each other equals plus or minus square root of 8. Okay. 8, our perfect square that goes into 8 is 4. Right? It is 4 times 2. This square root of 4 is 2, so that goes on the outside. And then this 2 has no perfect square in it, so it stays inside. Okay, so here x equals plus or minus 2 square root of 2. Okay. We're going to do this last one here, and then that's it. Okay, so again, I'm going to deal with outside of my parentheses, outside of my exponent first. So here, since it's a plus 10, I'm going to subtract 10. Okay, I'm left with x minus 3 squared equals 28. Okay. Then to undo my square, I'm going to square root it. Okay. This leaves me with x minus 3 equals plus or minus square root of 28. 28, we know, has the perfect square 4 in it. 28 is 4 times 7. Square root of 4 is 2. Square root of 7 doesn't have a perfect square. And then now all we need to do is add 3 on both sides. So x equals 3 plus or minus 2 square root of 7. Okay, you cannot combine these because this one has a radical and this one doesn't. Okay, so you just leave it as is like that. So x equals 3 plus or minus 2 square root of 7. Okay, that's it for today. Have a great rest of the day. Bye, guys.